Welcome to Understanding Experimental Probability. In this video, you will be able to determine experimental probability for an event. So your essential vocabulary for today is to understand that experimental probability of an event is the ratio of the number of times an event occurs to the total number of trials. Since it's a ratio, it can be expressed as a fraction, a decimal, and a percent. We will use the experimental probability equation. Experimental probability equals the number of times the event occurs over the total number of trials performed. Again, a trial is just the number of times that you do the experiment. All right, so let's look at an example. We're going to watch a short video on rolling a number cube. As you watch the video, please record tallies of how many times each outcome occurs, and then we'll calculate the experimental probability. All right, so I've recorded tallies for each event. Now let's work on our experimental probability. Well, experimental probability, again, is the number of times an event occurs over the total number of trials. So first, let's look at how many times did we get a 1 to occur. That's the probability of a 1 was one time out of the total number of trials. So we'll have to add. We had 1, 2, and 4 is 6, 7, 8, 9, 10. So we did the experiment 10 times. So the probability is 1/10. And since we're dealing with tenths, those are easy to turn to a decimal just by knowing our place value. So 1/10 is a decimal. And then as a percent, remember to turn a decimal to a percent, we move the decimal twice to the right. So 10%. Okay, the probability of a 2 in our experiment was also 1/10 and 10%. Probability of getting a 4. We had 4 times that we got a 4 out of 10 trials, so 4/10. Some people will simplify that to 2/5. Okay, as a decimal, 4/10. And as a percent, again, we move that decimal twice, it's going to be 40%. Probability of getting a 4, well, we had a 4 occur one time out of 10, so that was 1/10, or 10% again. Same thing with the 5. Okay. The probability of getting a 6, well, that occurred twice out of 10 times. Okay. Some people may simplify that to 1/5 also. Again, you move the decimal twice to the right to turn it to a percent, so you'll have 20%. All right, let's try the same thing with a spinner. On this spinner, there are 4 possible outcomes, or the sample space is yellow, red, blue, and green. So I've made a table. It's a good way to organize yourself when you're doing a probability experiment. We're going to record tallies as we spin, and then we'll calculate the experimental probability. So that's it. So now let's figure out our experimental probability. So the probability of getting red in our experiment, red occurred 3 times. Okay, the total number of trials, so now I'm going to have to add 3 and 5 is 8, 8 and 4 is 12, 12 and 3 is 15, so 3/15. All right, with 15ths, that's not as easy to turn into a decimal, but one thing I can do first is simplify that. I can get 1/5. Okay, 1/5. If I look 1/5 as to turn it to a decimal, we divide 1 divided by 5. Add decimal, we add our 0. 5 goes into 10 twice. So as a decimal, you could say it's 0 and 2/10. As a percent, 20%. All right, now let's look at yellow. We had yellow occurred 5 times out of 15 trials. If we simplify that, you get 1/3. Okay, 1/3 would be 1 divided by 3. 3 can't go into 1, so we add our 0. 3 goes into 10 3 times. And this is going to be a repeating decimal. So if we want to use that, we can just keep adding a bunch of 3's. That's what's going to happen. So we can show that 0.3 with the repeat sign over it. And as a percent, if I move that decimal twice or multiply by 100, I end up with 33.3%. And I'll put that repeat sign because it does keep repeating. All right, green. We had 4 times that we got green out of 15. I cannot simplify that, so let's turn that to a decimal. It would be 4 divided by 15. 15 can't go into 4, so I add my decimal and 0. 15 goes into 40 twice. That's 30, subtract 10, add a decimal and a 0, bring it down. Okay, 15 goes into 100, well that's 6 times. That's 90, subtract. End up with 10 again, so this is going to repeat also. So it's going to be 0.26, and the next digit would also be a 6. So when we turn it to our percent, it would be 26.6%. So 0.26 repeating, 26.6%. All right, and the next one is 3/15 again, because blue occurred 3 times out of 15, which was equivalent to 1/5, or 2/10, or 20%. So again, experimental probability is just the number of times an event occurs over the total number of trials. And you can express it as a fraction, since it's a ratio, a decimal, or a percent.